Welcome to really modules 13, 12, 13, and 14 kind of combined. Um, these are all additional information on countermeasures. We want to be able to direct our countermeasures for the problems that we're solving toward solutions that are more consistent with lean and operational excellence principles. So overall, we want our organization to be a lean organization, or we want to be an excellent organization. That means if we focus the countermeasures on things that are absolutely known to work in a lean environment, then that's really what we want to do. So we're going to spend a little time talking about flow and pull, and the main thing is really how do we create flow? A balance to flow is pull, and when we get through this first piece of this module, we'll have a solution that'll allow things to flow, but then we need to regulate that flow. So we'll put in a pull system, and we'll talk briefly about different types of signaling devices that allow you to regulate that flow, but we'll have a separate lecture on pull systems in a little bit. Our objectives here in this one are to evaluate, let me get my mouse working here. We're going to evaluate the effectiveness of various kinds of production control systems. We're going to create a pull system using several different types of Kanban. We're going to describe the effect of that type of control system on the velocity of the production system. We're going to create a work cell with multiple operators. We're going to balance the work within that cell. We're going to create a pull system to regulate the flow in that cell. And then we're going to evaluate the effectiveness of different types of inventory management systems. We're not going to get into a whole lot of detail on this, but we're going to talk about this at a relatively high level and see how it all applies within this simulation scenario that we've got with Yellow Promotions. So we'll first hit some flow and pull stuff. I want you to go back and review the baseline performance. So the round one performance back in module one, go back and review the video for the round one performance for Yellow Promotions. Make sure we understand what problems we had with that baseline round. Then we want to come back, we want to map the flow of the Yellow Promotions production system. We want to develop and test some countermeasures and create flow within that system, and then describe the benefits of a work cell, doing work in one place. So we talk about creating flow. It's not just to stop pushing things in. It's not just to write new software. It's a structural thing that we have to change. To achieve flow, we've got four distinct major steps: one place, one piece, one pace, one source. So it all starts with people, as you would imagine. With me, everything kind of starts with people and how do we make work better for those people. In many organizations, we got things scattered all over the place and there's a lot of moving back and forth. So what we want to be able to do is bring stuff to people in one place. So everything that we can move into one place so that we can start and finish a piece of work in that one place, that's our goal. Now, a lot of types of organizations, it's kind of impossible to move everything into one place. But when you start thinking about certain things, we often have purpose-built buildings, we have purpose-built machinery, and we say that we can't do anything else with those pieces of property. But that's not true. We just have to be a little bit more creative and try to bring that around. So the first lean ideal is to do as much work as you possibly can in one place. Once we get things nice and close and in one place, then we want to be able to apply this one piece rule. And that means we're going to reduce the batch size as much as we can to get as close to a one piece batch as we can, so we can make one and move one, make one, move one, make one, and move one. This is going to be counter to most of the things that you've seen in operating systems before. But this one step is the key to velocity. If you want to speed up your production system, this is the way you have to do it. Batches are very natural to us, so we'll talk a lot more about batches when we get into the one piece module in module 13. Next is to balance all of these workstations and all of these pieces of equipment and all of these tasks and all the work that people do. We're going to balance to the tact, and then we're going to level load. There should be a D on that, sorry. And we're going to run it according to that pace. The metronome is there to keep time. That sets the tempo, sets the pace for the work we do. But it isn't always locked in. You see on the metronome, you've got this little weight gizmo that you can move up to slow it down or down to speed it up. So occasionally demand changes. So we'll talk about how we can make adjustments to our production system in response to those demand changes. And then the fourth one is one resource. Sorry, I couldn't find a P word that actually rhymed and describe what we wanted to do. When it makes sense, we want to break out of those shared resources that are so common in conventional mass manufacturing systems. Remember, we said those conventional systems were all functionally laid out. If we get past the need to keep all like things together and start putting them where they're needed, you're going to see that we're going to be able to dedicate a lot more resources. So I've got a little bit of information on there about how to determine what is actually got to stay a shared resource and what needs to go. So let's start with one place, and this is the Yeller Simulations round 2. We're going to create some work cells because that's how we put things into one place. So let's take a look at the existing layout. Okay, so we started with the O writing and the H writing, and chances are when we started this company, this was our product. This was the one product that we made. So when we built a system to make this product, we kept these things pretty close together. So we had H writing and O writing there, and then we had clipping right close by. And then we put the stapler. Remember, the stapler simulates a large piece of capital equipment. It's not just an office stapler that you can go and run down to Staples and buy. This is something that is a huge piece of equipment, generally considered a monument in many organizations, where we're going to put it and we're going to install it, and it is not going to move. Does that mean we can't move anything else? No, we can move pretty much everything else. So we have the writing, clipping, stapling, and quality. And then maybe later we added this additional product, the IO product. And we already had O writing. We just had to find a new color. So we doubled the capacity of that one workstation. And now we've got 2 full products we can do, OH and IO. And the flows are, well, you saw them in the videos. They're a little bit crazy. We've got external flow that delivers paper to the 3 writing stations. That's all they do. They go back and forth, delivering to the 3 writing stations whenever the writing stations call for more cards. So that in itself is a pull system. Internally, we have internal transfers that really, it doesn't look so bad here, but between the O writing, the H writing, and the I writing, we have a lot of traffic moving back and forth into clipping. So in the simulation, we usually have 4 people who are doing internal transfers. And in most cases, they're bumping into each other, or they're trying to figure out who to respond to next. And it's just a chaotic environment. Not to mention the fact that we then pick up from clipping and move to stapling, and then pick up from stapling and move into quality. And then we'll go and ship it. So this is our spaghetti diagram for round 1 of the simulation. Let's make a value stream map, shall we? What would a value stream map look like? Okay, so we have our customer information up there. I've been playing around with the demand on this and things. When we did this exercise design, the data behind it was kind of a lower priority. We wanted to really focus on creating flow, and just so you could see how things flow. So let's look at that from a pretty high level. We've got the writing stations, H writing and O writing. We've also got I writing now, and then we've got material coming in to the writing stations. That comes from the supplier. They're going to bring 20 blank cards and distribute them on a pull system to each one of the writing stations. Then the writer's going to write and push out to clipping. Now, if you'll remember in the scenario, the writers we paid on a piece rate compensation. So the more cards that they could write and push out to clipping, the more money they were able to make. With clipping, we weren't really able to do that because they were constantly busy. So when we incentivize all four of these riders to go as fast as they can, and clipping is slow, it's no wonder that we had problems piling up at clipping. Then clipping would work as fast as they can in batches of 5 and push them out to stapling. And then stapling would push as fast as they could and send them out to quality or to be delivered. And then we'd add the timeline, and that's our value stream map. So where did we say we had problems? Let me get through the animations real quick. Where did we say we had problems? Let's see. We started with the high WIP at clipping. That was on the spreadsheet. That was the first thing that stood out. Lots of WIP at clipping, but we also had high WIP at stapling. We called that out. We were also frustrated with our low output. We also were frustrated that only a few cards managed to make it through quality. At stapling, we had a high changeover time. Between the writing stations and clipping, we had high traffic. And then often the writers were waiting either for cards from the supplier or more likely for a fork truck driver to come and pick up the cards. Because the rule for the writers were, when you finish writing your batch of 5 cards, you hold them up, you say parts, that's the signal for the parts supplier to deliver 5 blank cards. You can't write on those cards until the fork truck driver comes and gets this. So we put a couple of built-in constraints, and like I said, writing was kind of a pull system. That's probably why at the end of the round, they finished with the same amount of inventory as they started. So we know that we want to apply this principle one place, but we also want to make sure we're thinking about root causes. And in this case, nearly all of these problems can be traced back to the way that this functional layout inhibits flow. So that's our next exercise. I want you to be thinking about what you can put into one place. That means in these operations, what would you combine? Take a stab at the branching activity that starts just below this video. Work through that. I'll see you in each one of those, and then we'll come back and wrap this up.